If you spend your days installing IP cameras, access points, let's say in Starbucks attics, VoIP telephones, or other computerized devices, I have a device here that can save you hours of install time. And it can also help your customers in troubleshooting their own networks that you leave in their hands after your installation is done. It's called the power panel. It simply connects, in this case, in line between the switch that's keeping all of this together and the device you're testing, in this case, the camera. But before we go into detail about the power panel, let's just take a minute and talk about our demo setup here. We have a notebook computer that we're using as our surveillance display. It's connected to a computerized camera called an IP camera, and notice we have a live video feed going on. It's connected together with a switch, a 100 megabit a second switch, that's capable of providing power over Ethernet. Power over Ethernet is power provided on the same Cat5/6 cable that the data comes through. And the power can drive these computerized devices. What's so good about power over Ethernet? It saves you a lot of money during the install because you don't have to put in a separate AC power feed for each device. So you have the money savings of power over Ethernet plus the flexibility of dealing with digital pictures. That's why the IP camera market is growing so rapidly. Back to the power panel. In this case, we're connected in line between our switch and our camera. Immediately we find out there is a network there. There is power over Ethernet. Those are the two things we need for a reliable install. On our network screen, we see on pins 1, 2, 3, and 6 that there is POE end span. Oh, I'm sorry, this happens to be our power screen. On 1, 2, 3, and 6 there is POE end span, 46 volts, and the camera is drawing about 6 watts of power. The power is important because one of the reasons why networks fail is the devices draw too much power from them. And here's an inexpensive meter that can tell you quite accurately how much power these devices are drawing. Now let's switch over to the network screen. The network screen says also on 1, 2, 3, and 6, there's a network that is negotiated to 100 megabits a second full duplex, and there is data passing through. So again, the two things I need to know as an installer: yes, there's a network, yes, there is POE, and then I simply go to the correct screen to find out more detail. Had this been a POE injector, which are very popular, it would say 4, 5, 7, and 8. And that is called a POE midspan. And let me switch back to the POE screen. That would say POE midspan, 4, 5, 7, and 8. And you would also have the voltage and power readings. Now, let's disconnect completely and say we were not connected in line, and all we wanted to know is whether this switch had an active port, whether it had data available, and whether it had the power over Ethernet enabled. We simply connect it to either of the two jacks. Immediately it tells us yes, there is a network device, yes, there is power over Ethernet. We're on the network screen now. It says the network's on 1, 2, 3, and 6. The switch is capable of 10, 100, half and full duplex. Let's switch over to the power over Ethernet screen. It says likewise on 1, 2, 3, and 6 there is POE end span, 47 volts, and the camera is drawing a nominal amount of power. So here you have a device that can save you hours of time, and also, when given to your customers, can help them troubleshoot camera, IP phones, and access point problems immediately, saving you the trip out.